Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 1, Part 5B. And in Part 5A, we were dealing with 1.2 Scientific Inquiry. And previously we talked about uncertainty in air and how it's what you can't, the uncertain amount in a measurement. It's not that it's wrong. And how we use uncertainty in air when comparing data to see if the two trials are the same. And scientific experiments must be reproducible, and we need to be able to draw conclusions from our data. So we need to know what the uncertainty of our measurements is to know if we have significant differences between two trials or not significant. And a significant difference is when the difference between trials is larger than the uncertainty of the measurements. So let's look on page 20. Okay, so pretend you've done an experiment and you'd like to come to a conclusion. And you did two trials, Group A and Group B. And Group A had a temperature of 25 degrees Celsius and Group B had a temperature of 27 degrees Celsius. And previously, in the other experiment, we found as the temperature went up, the dissolving time went down. Whereas you can see from this experiment that when the temperature went up, the dissolving time also went up. So we're trying to see if we have evidence that refutes our original conclusion. So we see that the temperature was raised by 2 degrees, and that the time to dissolve was raised by 0.6 seconds. So what is the uncertainty with our measurements? So you can see that there's actually a wide range, of times. So our uncertainty is about 4 seconds, 48 plus or minus 4 is our range, our top and our bottom range. And over here, 49, and that's plus 3 minus 2. So the uncertainty in our measurements is 2, 3, or 4 seconds. So is the difference between the two groups larger than our uncertainty with our measurements? No, it's not, because the uncertainty with our measurements is about 4 seconds, and the difference in our data is less than 1 second. So we didn't conclude that that when temperature goes up, dissolving time goes up, because indeed it is the opposite. When temperature goes up, dissolving time goes down. Is the difference between Group A and Group B significant? No, we answer that. It is not significant. Well, scientific evidence needs to be objective, repeatable, and comes from experiments or observations. Objective means it is what it is. It's not my opinion, like I'd really like it to be longer or hotter or whatever. It just, I measure, is it hotter, is it longer, whatever. Repeatable, like I have said before, just because I do an experiment and nobody else does the experiment, it doesn't show anything. We come upon a real natural phenomenon, a real explanation, real conclusions when many people do the same experiment and come to the same results. And scientific evidence either comes for observations of the natural world, of natural phenomenon, or from experiments done in the natural world or in a more controlled laboratory setting. Scientific evidence always uses precise language. We don't want to confuse people with what we mean. So we have words and they have specific definitions, and that helps everybody out in the end. You got to learn them, but it helps everybody out in the end. And scientific evidence is often, not always, but often gathered using the scientific method. Question I have for you is, how familiar are you with the steps of the scientific method? Let's quick review them on page 26. So starting out with the scientific method, you observe nature, invent or revise a hypothesis, you test your hypothesis against any kind of observations, or you conduct an experiment with variables and measuring the dependent variable. And then you take that information, you share it with other people, you analyze it, see what other people have gotten, and then a whole bunch of scientists who have done experiments and have evidence come together, and usually there's a theory that rises out of that if it doesn't already fit into some other kind of explanation. And then there are more experiments that are done that will revise or strengthen the theory, and there are more observations and thinking that happens, and this just keeps going on and on. So if this seems like something you could repeat in your sleep, great. If this is something that you're not very familiar with, I want you to let me know. And that concludes our section 2. And our last section is going to be section 3, and that will be in our next video. All right, thank you. Bye.